If we accept the idea of weight being indicated by the tension in a string, then there is a very interesting consequence of that. I have here a pin which is completely frictionless, and I have on both sides a string, and this string has negligibly small mass. Let's just assume that it is massless. And there is here an object M1, and there is here an object M2, and I'm telling you that M2 is larger than M1. So we all know what's going to happen. The system is going to accelerate in this direction. M2 will be accelerated down, and M1 will be accelerated up. What comes now is important, that you grasp that. I claim that the tension on the left side must be the same as the tension in this string on the right side. T left must be T right. Why is that? It is because the pin is frictionless, and it is because the string is massless. Take a little section of the string here, a teeny little section. If there is a tension on it, there is a force in this direction, and there is a force in this direction, these two could never be different, because then this massless string would get an infinite acceleration. So there can never be a change in tension from this side of the string to the other. If you take a little section of the string here, there it is, teeny-weeny little section. So there is tension on the string, and there is tension on the string. This one could never be larger than that, because this little piece of string would get an infinite acceleration. So because there is no friction on the pin, and because the strings are massless, only because of that must the tension be everywhere the same. If there is friction in the pin, which we will do later, then it's not the case. Given the fact that the tension left and the tension right are the same, I must now conclude that these two objects have the same weight. Because didn't we agree that tension is an indication of weight? So these objects have now the same weight, and some people may say, oh, that's a lot of nonsense, you must be kidding. If M2 is larger than M1, this must have a larger weight than that. Well, they are confusing weight with mass. It is true that M2 is a larger mass than M1, but it's equally true that the weight of these two objects is now the same according to my definition of weight. Let us calculate the acceleration of this system, and let's calculate the tension. And let's see what comes out. I first isolate here object number 1. So this is my object number 1. I have gravity, m1g, and I have a tension T. Non-negotiable. T be better larger than m1g, otherwise it would never be accelerated up. And we know it will be accelerated up. So what do we get? We get T, I will call this plus direction, by the way, minus m1g equals m times A. So the tension equals m1 times A plus g. Hey, we've seen that one before. This one is being accelerated upwards. Notice it gains weight. That's the tension. And this is the acceleration. I have one equation with two unknowns. So I can't solve it yet. But there is another one. There is number 2 here. For number 2, we have a force, m2g, and we have the tension up. This one better be larger than that one, otherwise it wouldn't be accelerated down. Let me call this direction plus. The reason why I now switch directions and call this plus as well as this is a good reason for it. It's not so arbitrary anymore. I know that this acceleration is going to be a positive number because it's going in this direction, it's a given. If I called this negative, I would get here a negative acceleration for the same thing for which I get here a positive. That's a pain in the neck. I don't want to have a plus and a minus sign there, have to think about that it means the same thing. So the moment that I define this the plus direction, I know that this acceleration will also come out to be the same sign as this one. So I flip the signs there. So now I apply Newton's law. I get m2g minus t equals m2a. And so I get T, I write it here, equals M2 times G minus A. Two equations with two unknowns. Well, that shouldn't be so hard to solve these two equations. You can immediately eliminate T, by the way. If you add this one with this one, you already, I call this equation 1, and you call this equation 2, you immediately lose your T, and you get that the acceleration A equals m2 minus m1 divided by m1 plus m2 times g. And you substitute that A in that equation, and you'll find that the tension equals 2mg divided by m1 plus m2. This is very easy for you to verify. Let us look, this is m1, m2. 2m1, m2, I lost 1m, 2m1, m2.